Hello students, welcome back to the next module of the chapter Oscillation. Students, in this module we'll continue with numericals on energy in SHM. So let's start with our first numerical. A particle executes SHM of amplitude A. At what distance from the mean position is its kinetic energy equal to its potential energy? So the given is kinetic energy is equal to potential energy. And to find its distance from mean position, that is I have to find x when kinetic energy is equal to potential energy. The required formulas are, as we have to equate kinetic and potential, so we have to know the formulas of kinetic energy, which is half k a square minus x square, and the formula of potential energy, which is half k x square. Let's start with the solution, students. Solution starts with the given itself. So k is equal to Pe, which is given to us. Let's write the respective formulas on both the sides. That becomes half k a square minus x square is half k x square. Let's cancel half and k from both the sides, and therefore the next step becomes a square minus x square is equal to x square. Taking x square on the other side, it becomes a square is equal to 2x square, and hence students x square becomes a square upon 2, and taking root on both sides we get x is equal to plus or minus a upon root 2. 1 upon root 2 is 0.7071, and hence students answer can also be written as x is equal to plus and minus 0.7071 a. Let's see the next numerical, students. A particle executing SHM of amplitude A. What fraction of total energy is kinetic energy when the displacement is half the amplitude? And the second question, at what displacement is the kinetic energy 3 times of potential energy? So given in the first part of the question, it is given that the displacement is half the amplitude, so x is equal to a by 2. In the second question, kinetic energy is 3 times potential energy. To find us the first part, what fraction of total is kinetic? So it's a ratio problem, that is we have to find the ratio of kinetic energy upon total energy, but when x is a by 2, and the second question is I have to find displacement, that is x, but when kinetic energy is 3 times potential energy. The required formula for this numerical. Students, as all the 3 energies are involved, so we should know the formulas of the 3 energies, that is kinetic energy half k a square minus x square, potential half k x square, and total energy half k a square. Let's solve the first part of the question, students. So when x is equal to a by 2, I want to find the ratio of kinetic upon total. So kinetic energy half k a square minus x square. Let's write down the value of x. It becomes half k a square minus a by 2 the whole square, which in the next step becomes half k a square minus a square by 4, which becomes half k in the brackets 3 by 4 a square. I can also solve it further, but since it's a ratio problem, cancellation will take place, so let us keep it as it is. We know total energy is half k a square. Now let's take the ratio. Therefore kinetic energy upon total energy will become, yes, the formula of kinetic energy is here, that is half k 3 by 4 a square upon half k a square. I will cancel half and k and also a square. Therefore the answer is 3 by 4. Let's see the next part of the question. I have also to calculate displacement when k is 3 times Pe. Let's write down the formulas on both the sides. I will cancel half k, and the next step becomes a square minus x square is 3x square, which students can become x square is equal to a square upon 4. Taking root on both the sides, we get x is equal to plus and minus a by 2, and also we can written as x is equal to plus or minus 0.5 a. That's all in this module, students. See you in the next one.